Hello, AP Psychology students. Today we're going to look at Module 23, which looks at our sleep patterns, like our biorhythms and theories of why we might sleep. So we're going to focus on, the biorhythms and then how biology and environment might interact to, affect our sleep patterns. So the first thing, probably the most important thing I would want you to get from this whole video would be to understand the idea of a circadian rhythm. This is technically any rhythmic change that's roughly, you kind of go in a 24-hour cycle. It's not just when you sleep and when you wake up. All that's probably one of the most important ones, and the one that we think about the most is within a 24-hour cycle. When do we tend to get tired, and then when do we tend to have the most energy? But other things can change throughout the 24-hour cycle as well. Things like body temperature, sleep, and wakefulness. So think about times in the day when you feel like you feel the best, you have the most energy, and then what are times of the day where you feel like your energy kind of dips a little bit. This would all be a part of your circadian rhythm. What's interesting is that for young people especially, that if we don't have what's called time cues, meaning an alarm clock, like I got to get up, I got to go to school, I got to go to work, that oftentimes our circadian rhythms are a little bit longer than 24 hours. They can be anywhere from 25 to 27. So you might notice during breaks, summer break, winter break, etc., that you go to bed at a certain time one night, and then the next night you stay up a little bit later, and then the next night a little bit later, if you have nothing to get you up in the morning. So that's part of the reason why sometimes young people can really get their schedules out of whack. The other thing is young adults, people your age, so adolescents into early adulthood, tend to have later circadian rhythms than older adults. So I always like to use the analogy of, think about the difference between a college dorm and a nursing home at 10 p.m. In the college dorm at 10 p.m., night's just getting started, right? But at a nursing home, most of those people are asleep by 10 p.m. and they may have been asleep for a little while. So just think about the difference, between young people and old people. Understand that a difference exists, and that a lot of that is kind of biological. So it's not like, oh, you're just a lazy person because you sleep in or whatever. I guess it's possible, but generally it's going to be mostly biological, whether you're a night person or a morning person. Societally, we kind of put more emphasis. We kind of prize being a morning person. Think about, the early bird gets the worm. You got to get up early and work hard. But what's really the difference between you get up super early and work, and then you go to bed at 9 p.m. versus someone who stays up late and works? I don't see the difference there, but our society tends to have a preference. So understand too that we talked about biology affecting the circadian rhythm specifically. There's a little mechanism called the suprachiasmatic nucleus. We're just going to call it the SCN, and it's in the hypothalamus. Which you're going to learn the hypothalamus kind of does a little bit of everything, it feels like. So this is the mechanism that helps regulate your circadian rhythm, and it does that through the regulation of melatonin. You may be thinking right now, hey, I've heard of melatonin. I take that to sleep sometimes. So just know that your body makes this naturally, and that helps you kind of sense like, hey, the day's winding down, I should start feeling tired. So this is going to be secreted more later in the day to kind of help you become tired and go to sleep. Understand that light and technology can influence your ability to fall asleep, especially like the blue lights that are on computers and tablets and phones and those kind of things. And they can kind of trick your brain. So that light can get in there and trick your brain into thinking, hey, it's light out. It's not time for bed right now. And this can, again, trick you into staying up later than you should. So one of the big things that, we kind of worry about with young adults is if your phone's next to you all night, maybe even into the middle of the night, that phone could maybe be screwing up your sleep because it's not allowing your SCN to regulate melatonin properly, and that's messing with your circadian rhythm and again, making you stay up late. So there's a way, I think, of turning off the blue light at certain times on your phone, so you'll have to look into that. And then kind of getting into the stages of sleep, you do want to know these. So I'll kind of break it down for you a little bit. Understand that the way that we know these is through the invention of a brain scan known as an EEG. It actually kind of got started with a researcher. He took his son with him to work, and he was like, oh, well, we're just kind of screwing around. He had his son lay down, and he hooked up all these wires to his kid's head, and because the EEG does more than just sleep studies, it also studies other brain functions. But he hooked his kid up, and his kid went to sleep, and he found that throughout the course of the night, like the electric activity in his brain was changing very frequently, and so that it's kind of funny, but that's kind of how the study of sleep and sleep stages got started. So they put electrodes on your scalp, and then it provides a record of the electrical activity. If you've ever had a sleep study or know someone who's had a sleep study, this is what they're doing. And so we're seeing differences in people's psychological states in different stages. So for the stages, don't get too wrapped up in like memorizing the different, like the length of the waves and alpha and delta and those kind of things. But I do want you to know what each stage, at least the research claims to know about it. So bottom line, the slower the wave, the deeper the sleep. So these big, deep waves, that shows that your brain is thinking more slowly. So when you first fall asleep, you go into what's called non-REM or NREM1. This is like the first few minutes when you're first falling asleep. You might experience some mild hallucinations, kind of like you're drifting. You may even have that sensation of falling. You have to catch yourself. This is called a hypnagogic jerk. But bottom line, you don't spend a lot of time in this stage. You do spend a lot of time in what's called NREM or non-REM 2. They think that non-REM 2 is involved quite a bit with memory consolidation. So like your hippocampus communicating with the other parts of the brain and kind of sending those memories off for long-term storage. Stages 3 and 4, they actually condense these. There used to be a stage 4, but now there's just a stage 3. So this is considered slow wave sleep. So this is when you are like, this is, if you have like a Fitbit on your phone, they call this deep sleep. And then stage 2, I think, would just be like light sleep or whatever they call it. So stage 3 is the deep sleep. So, the waves get bigger on the machine. If you've ever been woken up during this stage, you're like extremely groggy, like where the heck am I? Like, how did I get here kind of thing. People, kids, if they struggle with bedwetting, they generally do this during deep wave sleep because they can't wake up enough to get that signal from the brain that they have to go. Sleepwalking. A lot of people think that sleepwalking happens while you're dreaming. That's not the case according to research. So sleepwalking actually happens during deep wave sleep. You're actually very much asleep when you're sleepwalking. Very hard to wake someone up in this stage. This is, so stage 2, what we think is that is mostly involved with memory. Deep wave sleep is more important for like replenishing the body. So like repairing the body after, the day's activities. And so you'll spend more time in deep wave if you exercise more. So if you work out and you kind of break your body down, this is going to be used to build your body back up. It tends to also happen in the earlier hours of sleep. So the first couple hours, you're going to spend more time here. And then as the night progresses, you'll spend less. Oh boy, this is kind of looks intimidating to look at. What I want you to understand with the stages, though, generally speaking, is so you're awake, and then when you fall asleep, you go stage 1, stage 2, stage 3. And then you go, think of it like going down the stairs and then up the stairs. So stage 1, 2, 3, back to 2, and then you hit what's called a REM cycle. We'll talk about REM here in a minute. And then you go 2, 3, 2 REM, 2, 3, 2 REM, so, and then as the night goes on, you're not gonna spend much more time in the deep wave sleep. You're gonna spend more time in what we call REM sleep. So have a basic understanding of that order. It doesn't go 1, 2, 3, 1, 2, 3, 1, 2, 3. You don't spend very much time in 1. It's mostly gonna be 2, then 3, back up to REM, so 2-3, 2 REM, 2-3, 2 REM. So REM sleep, REM stands for rapid eye movement. And so the key thing here is your brain activity is actually very similar to when you are awake when you're in REM sleep. Also, your muscles are relaxed. They generally are paralyzed, because also this is when you dream. So this makes sense because you don't want to be like acting out your dreams and fighting ninjas and stuff. But your eyes kind of dart back and forth when you're in this stage under your eyelids. Dreams occur, genital arousal happens for everybody. They call it paradoxical sleep because your brain is super active, but your body is paralyzed. Again, we don't want you acting out those dreams. And again, you're going to spend more of this, you're going to have this later in the night. And they think also, along with stage 2, REM sleep is very, very important for memory, but also like cleaning out the gunk, like getting rid of the information you didn't use. But also there's a mechanism where when the neurons communicate, it kind of produces this byproduct, and the REM sleep kind of cleans everything out. So this is super important. And what's kind of depressing is if you don't get enough sleep. So if you're supposed to be getting 8 and you're only getting like 6, a lot of what you're missing is the REM. And if you miss a lot of REM, what you'll find is that the time that when you are able to make that up, you'll experience what's called REM rebound. So with REM rebound, you have an increase in the amount of time you spend in REM compared to average. And this is a way that your body's trying to make up for that lost REM sleep. So I think that's a good place to stop. It's pretty deep stuff. So we'll have another video over the rest of the stuff on sleep. So today we kind of looked at the circadian rhythm, some of the biological things that relate to that, and then we looked at the stages of sleep. So we'll have another video here shortly and talk to you soon.